Hey, hello. Hi, everybody. Feel like we're still missing some people, but I'm going to get started. It is 6:40. How's everyone doing? Good? Yes, feeling good. Yesterday you guys covered functions, right? How are we feeling about that? Good? Strong? Okay, so today's lecture, I'm going to go off the assumption that everybody understands functions and the proper syntax and usage. And we're going to dive into a little bit more of a computer science topic today. We're going to be talking about scope, which is fortunate because I'm excited because I know I'm going to talk about let at some point. It's really an important topic. And we're going to talk about kind of the lifetime or the life expectancy of variables. Where do we expect variables to exist and not exist? And this is something that you might have gotten a feel for as you've begun your programming journey, but we're going to kind of make it a little more concrete today. Okay? Then we're going to have this very controversial part 2 lecture if we get to it. And the reason why I say controversial is because I like to do it because I think it provides immense benefit beyond this class. It is a topic that you will not be tested on for bootcamp entry. I choose to do it depending on how I feel this class is doing on the first half of this lecture. So, and here's kind of an overview of that. So one thing we talked about is that JavaScript is a higher order language. A higher order language. What does that mean? What does that mean? What do you need to be a higher order language? I'll give you an example. Java is not a higher order language. JavaScript is. Has something to do with functions. So yesterday, when you talked about functions, right, you talked about parameters and return values, right? Right. So what can be a argument to a function? Like, what can I pass to a function? Can I pass arrays? How about strings? Numbers? What about other functions? Yeah. So that's kind of what this dives into a little bit. Is these higher order functions. What makes JavaScript a higher order language is the fact that functions can be passed around just like variables can, right? And so we can have functions that take in functions as parameters, but also functions that will return functions as output. And so that's something to keep in mind as well. Now, because of that, it does create some complexity in terms of scope. And that's what part 2 of this lecture will deal with, okay? So game plan, I'm going to go through part 1. It's going to be about scope, required. Everybody's got to be on board with me. Part 2 is going to be a step beyond. And again, this is getting recorded, so you can come back to it if you feel like you're not comfortable with it today. And then we'll have questions as usual. Any questions on anything before I get started? Yes?
I'm still not clear, and this was in one of the problems, I guess, on passing a function as a parameter.
Sure, I can go through a quick example of that.
That would be excellent. Thank you.
Sure. Anything else? Yes?
Yesterday we were told we would get the beginning of this class to work on the problems last night. We were only given like 30 minutes to do them. Is that not happening?
Okay, we can do that, but I'm gonna cut that closures lecture then, if that's okay with everybody. So I think probably the better. Let me just check one thing real quick. We might be able to do something. How many of you need more time on yesterday's problems? Like everybody needs more time, right? No?
More time in the sense that I didn't finish them, but
Okay. So I think would it be okay if we continue like during your problem set today when you get to it? First of all, I'd like to say this: the problem sets are made for you not to finish them. Okay, we give you more problems that you can handle so that you'll have some stuff left over generally for the weekend. If you do get through it, great, right? But if you have extra stuff, then that's okay too. If there is a day where I know Leanna mentioned that you guys had a short period of time yesterday to actually work on this stuff, and I'm glad you reminded me about that. My personal opinion on that is, if that happens, that's okay, especially because it's week 2. So I think it's more important for us to spend more time during the lecture and let you do the problems over the weekend and kind of ask, we have fellows that you can more than welcome to ask questions to, or even me after the class is over on anything, okay? Starting next week, this is going to kind of flip a little bit. You're going to see a lot less time spent on the lectures and a lot more time spent on the problems. And that's because as the topics get harder, it becomes more important for you to practice more than just hear us talk about it. So is that okay with everybody if we just kind of move right into the lecture for today? All right, cool. On that note, let's talk about scope. Okay, so this is something that you're going to walk out of here today not being a better programmer. I know that sounds like, why are we talking about this? But it will absolutely let you debug, find mistakes in your, like, okay, I will tell you, this is something for me that I considered, that I don't think about very often. It'd be like a doctor learning about a rare disease, and like when he's going to school, and then like having a patient having to like you would never think about that first, right? I had a bug about a week ago that it took me 4 hours to literally trace this whole thing back, and it turned out to actually be a scoping problem. I'm going to show you guys that at the end of class. It's something that I don't think about that often, but it's something that you will be ingrained on how to write code so that issues do not occur. These are rules that exist, not something that you can let's say change or implement, right? These are things that exist. This is the way that it is. And so I urge you to think about that as I go through this lecture. Okay, so what am I mumbling about? What is scope? Well, scope is the set of variables that you can access at any given point in code. Okay, so as of right now, we're writing these small chunks of code in a REPL, right? But you can imagine that real applications are thousands, tens of thousands, hundreds of thousands of lines of code, right? Where is a particular variable accessible and where is it not starts to become a much more important question, if not more of a confusing question at that point, right? For us, we're just saying, var x is equal to 5, do something with x, boom. There's not really a loss of scope there. But you'll see as our problems get a little more convoluted, as you guys start working on your home projects, right? You guys were Leanna talked to you guys about Sudoku? Yeah, okay, so as you guys start working on that, next week you'll have one on poetry generator. So you're going to actually see a much more applicable answer to this about when you actually have to keep this in mind while you're coding. Again, it's something to keep in mind while you're coding, not like a practice of how you code. Okay, so here's really the main takeaway. Functions, the word function creates scope. In var land, the word function creates scope. So any variable declared with the var keyword is automatically kept at whatever functional level it is declared at. Now, when I look at an empty REPL on my screen, right, I want you to think of an empty REPL as just an empty function. And when you click run, it's like invoking your function. Can everybody imagine that? Right? That's what's going on in your REPL. So it's not really like this global scope. You have this little window of code that you're writing, and that's a function, okay? So anytime you use the var keyword in that REPL, anytime, it is available throughout that entire REPL. Here's what I mean by that. I also realized that I totally just skipped over that inputting a function example. I'm going to do that right now. Sorry, I got excited. I just wanted to talk about scope. Okay. All right, so while I was on the topic of var being, so right, this is a magical function right here that when I click run gets invoked. Okay, I'm going to come back to that in a second. And so if I write something like this, console log of x, and then I say var x is equal to 5, how many of you think this is going to throw an error? If I didn't just give that speech, how many of you think thought this was going to give an error? Yeah, right? So if I didn't just say what I just said, you probably would think this was going to give an error. But actually, var gives scope in the entire function, okay? So if I run this, var is actually going to, this x has actually been declared, but its value has not been set. And that's how we get this printout of undefined. And we're going to talk about how that actually happens in just a moment. Just a moment. So bear with me. Let's go back to that problem from yesterday, right? So quickly, functions that take functions. All right, let's call this function runner, which takes in a func and it takes in a number. Okay, that's all this function is going to do. Now let's write our own function, okay? And this function is going to be called add2, okay? And it's going to take in a number and return n plus 2. Any questions on add2, right? If I invoke add2 with the number 2, I'm going to get back a 4, right? Everybody's with me on that? Yes. Okay, so here's what's cool. I wrote this function runner that has no idea about the existence of add2. In fact, if I wrote a separate function called subtract2, right, and it takes n as a parameter, I'm going to return n minus 2, right? Also independent of this function runner. Cool? So now what I can do is I can use this runner function without caring about who wrote what function. So now I can do something like this. I can say runner and pass it add2. So now I'm taking this add2 function and shipping it off to our runner function. Okay? And I'm going to pass it the number 4, whatever. Okay. So now when runner gets, at this point, right now, runner has access to 2 arguments that were passed in, right? The original function that I decided, because I'm the programmer and I wrote add2. You guys had no idea about add2. I wrote it. Okay, and I'd like to use this existing runner function. Now, all this runner function is going to do is take whatever func is passed in and invoke it with the number. And now, let's return that. Cool. So now we have this runner function that's just a completely modular function that all it does is take a function and some number and invoke that function with that number. That's all it's going to do. It's regardless of whatever I have out here. When I go to actually use runner is the moment we care about what function is available to us. So right now, if I do runner add2 at this line, we'll see that this comes back as 6. 6, because I passed in the func add2 and the number 4. So it invoked add2 with the number 4, right? Giving me back 6. Okay? Let's take a look at the call stack here. So I don't want to actually go too much into call stack. Forget I said that word. Let's talk about the program flow here. The program flow. So runner add2 gets called. This is line 4, right? This is line 11, right? So at this moment, all that we've done is transfer. Think of this as like your attention, right? Whenever you run code, you can only have your attention on one thing. We say we can multitask, right? But we can't really multitask. We have our attention on one thing. And that's just like our code. So we're going through our code and we hit line 11. This is our first piece of code that actually executes. And we call runner with add2 and 4. At this moment, our focus changes and we move into our runner function, right? Func gets defined as add2 and number gets defined as 4. Now we get this return keyword, right? So we're looking to return something back to right here. That's what we're looking to do. But unfortunately, we don't have a primitive data type that we can just send right back. We have another function call that happens, right? And so because this function call happens right here, we basically have to change our attention again. And we have to now take a look at whatever func is, which is add2, right? So now we turn our attention to the add2 function, and we're passing it number, which was 4. And now we're here. And now we're going to return 4 plus 2, which is 6. So we evaluate that, and we return that back right to here. And that gets evaluated immediately, right? Return of 6. And now we can take that and send it back there. Does that make sense? Now what I could do here is I could actually swap out add2, right? And totally put in subtract 2. And now we'll see another thing happen because I passed it a different function.
Does it matter the order then?
Did you go over function versus variable declaration? Yes, right? So you're saying like, why was I able to do that? You know what? Let's go into that right now. So that's kind of part of our scope lecture. Did you guys talk about hoisting?
Yes.
All right, I'm going to do it again. Here we go. So I think it's really important to remember, what are the three pieces that happen in hoisting? What are the three things that happen? What gets hoisted all the way up to the top? Yes, what's your name again?
Mark.
Mark.
Function declaration.
All functions get hoisted up to the top of our code. So this code actually looks like this. This is what this code looks like to the compiler. Step one. What's the second thing that happens? And now we get to today. So the second thing that happens during hoisting is all variables declared with the var keyword get hoisted up to the top. So let's go ahead and take a look back at our example from before. Okay, so that answers your question, by the way, right? About why we were able to do that. Because using that function keyword, it doesn't matter where I put it. If I put this over here, the engine that's running this code is just going to move it above it anyway. Doesn't matter. That's what happens during hoisting. Yes? Why does it do that? So the JavaScript engine makes three passes through the code for optimization reasons. JavaScript's a functional language, and so functions are given preferential treatment, and so that they're declared so that they can be used anywhere within the code. In case there's thousands of lines of code, you don't need to worry about where you're declaring a function. You can declare it right in the middle of, a couple hundred lines, and boom, it'll get hoisted right up to the top.
So the first thing the engine does when you run code anytime is look for functions.
Yes, anything with the function keyword. I mean, it might do some cleanup work or some other background, but the first thing in terms of code that it does is, yes, it takes functions and rips them up to the top. Yes?
And so it knows that func refers to a function because of the syntax of having the parentheses around number, right? So it knows that that's actually some function that's passing a parameter number, right? And then it knows to look for a function.
Here, I'm just using whatever was passed in and invoking it. If it's not a function, I'm going to get an error. Make sense?
Yeah.
Then somebody's not using your code correctly, or you can protect against that, right? I can say if type of func is not equal to a function, something like that. I can do that if I wanted protection. Okay, so step one, all functions get hoisted to the top, right? Everybody's with me? Okay, this is really important because we're actually going to talk about step two today. So now let's go back to this example. Let's say I do this. Var x is equal to runner or whatever, right? So this makes sense, right? Because we're expecting the runner function to return me back a number anyway, right? So why can't I just assign it to a variable, right? So here, let's go through this one more time. We have runner getting passed to a function and a number. That function gets invoked with that number, right? And then we go up to that function, invoke it with that number, get that return value, pass it back here, get that return value, pass it back, and now x is equal to whatever the invocation was. You guys with me? Okay, cool. So now x has a value. So the second thing that happens is all variable declarations get hoisted up to the top. So now this code actually looks a little bit different. What happens is this function, right? First thing is we go make that first pass, boom, we get that function just like that. The second thing that happens is we move all variable declarations up to the top. But assignments are kept in place. Variable declarations are moved to the top, but assignments are kept in place. So this is essentially what your code is looking. This is what this code would look like when we actually go ahead and run it. Now let's go back to this example that I did earlier, which was when I did this console log of x, right, and var x is equal to 5. Now we understand why we're not getting an error, right? Because the first thing we try to do is hoist functions up to the top. We don't have any, right? The next thing we're going to do is hoist our variables up to the top. So now this console log x is actually happening after x has been declared, right? It will then print out x, and then x will be set to 5. That is the actual order that this code will execute, even though I wrote it like that. And that is why we get x as undefined. I think that transition worked awesome, right? That was good, right? Between those two? Nailed it. All right, cool. Any questions on that? Hoisting, yeah.
If like the variable is global, is that so
So if I do something like this,
like it's a global variable that you cannot change,
so if that's a great question. Like, so if I don't use a variable declaration, which is making it global in that sense.
no, like if it's not inside a function, it's just above before you start writing a function, you just put variable x.
Okay,
Outside
that
global.
is the next thing we're going to talk about, which is actually scope. How do we create new scope, right? We're like dealing with this one level right now. We're not dealing with like, what if a function has variables outside of it? Can that function use it? That's basically what you're getting at, right? Like if I do something like this, right, and then I say function do something, and all this function does is console log x.
And x can never be changed inside.
Right, so now you're saying, like, if I call do something, will that work? Who says it will work? Who says it won't work? So the answer is it will work. The reason is the following. What's the first thing we do? What? Functions go up to the top, right? What's the next thing we do? Variables get declared. And then x is equal to 5, right? Notice that do something still happened after all of that, right? And so because the invocation of do something happened after, right, x was already assigned to the value of 5. And therefore, it was able to exist inside of that function. So remember I told you to imagine this REPL window, right, as like this as a function. This REPL window right here, this is a function. But then this is sort of a function inside of a function then, right? We're going to start diving into that in a minute. Yeah, do you have a question back there?
Yeah, so if you reassign x inside the function, how does it get changed?
Let's do the lecture, and then you guys can ask those questions. That's scope. That's scope. Yes.
Just to clarify, so function invocations don't get hoisted. Function declarations do.
The only things that get hoisted are
Yeah.
functional declarations and then declarations of variables using the var keyword.
Okay, the invocations actually happen in order. Talk about.
Yes, everything else is in order.
The definitions get like separated from the var keyword or something.
Only if they have the var keyword do they get hoisted in this order of operations. Mm-hmm.
Is it good practice to just write your code the way that it would be hoisted? Is that generally what's done?
I would actually no. I would say no. I would say functions are almost certainly done in order of like logical like let's say a function depends on some other variables. You would declare that function after those variables, just out of practice. But good question. All right, let's get on with the scope lecture. And now with all this knowledge, I think these quizzes are going to be a lot easier. But let's go ahead and give it a shot. So, okay. So the only time a new scope is created is inside of a function. Only time a new scope is created is inside of a function.
Like a function and a function?
So, right, remember, our page is a function, right? And then this function was declared. This function all of a sudden created a new scope, which is going to dive into the overlapping variable problem. But
That's not called a nested function, right? Is that not like if a function is in a function?
oh yeah, that is exactly what we're dealing with. Yeah. So that is what's happening. Every time you're declaring a function, it's like as if you're declaring a function in a function. Exactly. Okay, let's take a look at this problem. Does this work? Yeah, right? This is pretty straightforward. We have add 5, which takes in the number 3. Num is declared as 5. and we return 5 plus 3, which is 8, right? So we're going to get an output of 8. Let's try this. So we have var num is equal to 5, right? Function add 5. What about this? Does this work?
It doesn't look, yeah. Wrong.
Does anyone say no? Sure.
Yeah.
Yeah.
You try.
Right, so let's follow the logic here, right? What we're doing is we're calling add 5, and we're passing it the number 3 and the number 5, right? And so at that point, this inner function creates scope at this moment, where n gets the value of 3, and a brand new num gets declared with the existing value of num. Okay. At that point, we passed in 3 and 5, and we're going to return 3 plus 5, which is 8. Let's keep going. Think about it. Don't call it out. Let's give it another minute. Who says yes? This will work. Who says no? It's not going to work. Why won't it work?
It's not calling the variable. It's not doing what the function is intended to do.
So what gives you that impression?
Because the function add 5 is supposed to add 5.
Well, num is 5. Yeah.
So if the function declaration is hoisted to the very top, then it doesn't have num at that point, because even the assignment of, or even the declaration of num would be beneath that. I'm not sure if that's right.
Not quite, right? Because this function will get hoisted to the top.
Right.
Then our variable num will get declared. Then num is going to be equal to 5. And then we actually go ahead and invoke our function. So num will be available to it.
Oh, yes. So it goes by.
So the actual answer to this is yes, it will work. Yes, this will work, right? So we have our number being declared, like I said, and when we call add 5, right, n is now going to represent the number 3. Num, right, doesn't have a value. See, this is where it gets a little funky, okay? At this very moment, remember how I said JavaScript will do like almost everything in its power to not throw an error? Like, that's true. Like, JavaScript is so awesome in so many ways and lacking in so many others. Because with JavaScript, if you do something, like when we talked about variable types, right? We can move from one type to another really, really, really easily. But the flip side of that is we need to be careful about what types we're using at any given moment in time. Okay? Here's another example of that. Like, at this moment, num does not exist at this level. Right? In fact, when we try to return something that's undefined plus 3, we should get not a number. Right? Because num does not exist within this function. But what happens is, it's going to continue looking for a possible value of num until it has nowhere else to check. Okay? Always starting from the innermost place. So at this moment, num does not have a value. Right? And because of that, instead of throwing an error, instead of assuming that num has not been defined and like, let's throw an error and get out of here, right? It's going to go, hey, does my parent function have that value defined for me? And we can see that it does. And because it does, it's going to use that. The reason why I'm using this very specific terminology is because we can override a variable locally. We will always go with the local value of a variable before going with a parent's value of a variable. Okay?
You mean global? Global and parent?
No, they're not the same, right? Global is the most parent. Like global is like the grand, like the biggest parent that you can have. It is available everywhere, right? But you can have a function in a function in a function in a function, right? And then the innermost function, its parent wouldn't be the global scope. It would be the function that surrounds it.
So the second one and then the third one would be like the grandfather. No?
Right. I mean, yeah, but you just call it parent and child
Okay.
generally. Yeah. Okay, what about this? Does this work? Who says this works? How about who doesn't think it works? Why not? Someone wanna?
Not to find the type
Can we,
function.
let's raise our hands. Good. Sorry. Yeah. Yeah. Well. Wait. Your name one more time.
Bobby.
Bobby. Right. I knew that. Sorry.
Yeah, number doesn't exist because that function was never invoked. Right?
Yeah. So even if I invoked create num over here,
Yeah.
it wouldn't get invoked. It would. I mean, it would get invoked. Sorry. It wouldn't exist. It wouldn't exist. See, what's actually happening here is very interesting. Right, we have our parent function, which is our REPL window, right? Everybody's with me on that, the parent function, right? That parent function has 0 variables defined in it. Really, it has 0 variables defined, right? Now, there's 2 child functions here to that parent function. There's create num and add 5. And other than the fact that they share a parent, they have no relationship to each other, right? So just because num is defined in one doesn't mean that it exists in others. This is actually a really good thing, right? Because now we're able to have variables in our own functions without worrying that somebody else wrote a variable with the same names and same. This happens all the time, right? You can imagine I wrote a function today. I don't need to go through hundreds of thousands of lines of code looking to see if somebody else wrote a function using the same variables, right? That's not an issue because my function is isolated from all other functions. Okay. So this will not work. And this is going to give an error because num is not defined at this point. Cool. I want to do an example.
Those aren't in the slides, right? Because I only saw one of them.
Hmm?
The other 3 of them, the last 3 weren't in the material.
I don't know what you're referring to.
So, you know, when you click like where the slides, they weren't in the slides in the material.
Oh, this you're saying you don't have access to these slides?
Yeah.
You shouldn't have access to these slides yet anyway.
Oh, okay.
So I think you know why? Because we didn't change this slideshow since the last cohort. And so therefore you guys probably have access to the slides already. Right? You guys were able to see the slides under materials?
No, the last one is intro to code organization and functions.
So where did you get this slideshow?
I didn't. That's what I'm saying. I didn't get it. I don't know if it's supposed to be out there. Did you post it up already?
No. I will always post after the lecture. I will never put up my slides before the lecture.
Okay.
I know Leanna does that.
Yeah. That's
I will never do that. I don't like to do that. I think that it's more important because like sometimes you end up trying to like. I really believe there's like 3 types of learners, right? There's like, and you can be a combination of any of these, right? But some people are really good at reading and learning, right? Some people are really good at like getting like those pre-readings are really helpful. Like, hey, give me something to read. I'll read it. I'll be ready to come into class and go, right? Other people will get that pre-reading and be like, all right, I tried. I did not get that at all. I can't just read some book and get it. I'm like that. I personally, we give the pre-readings because a lot of people are better with that kind of learning. Some people need that before they come to the lecture. Some people like the lecture style and this kind of interactivity gets you, right? There's the third type, which I think everybody really is at some level, is actually practicing it and reviewing it and talking to each other about it. And I think that's probably the best. So we really give you 3 opportunities to learn the same material here. But when you're listening and you're using like kind of auditory like learning, I feel like if I give you the slides in front of you, it can kind of distract you from what's going on up here. So I don't like to do that. Yeah.
A question about this right here. Let's say on line 34 you call the function create num, but as the code runs, the garbage collection will get rid of the variable because it's not the num variable because nothing's being done to it, right? Is that
Great
true?
question. So actually, yes, it will be picked up by garbage collection, which
Is that why it doesn't work though? Even if you call create num on line
no,
34?
it's because it loses its scope, right?
Oh, yeah.
So if you called create num right here, that's what's the question right now. What happens if I invoke create num here? Why is this throw an error? Why does this throw an error? Well, because when I call create num right here, we enter this create num world, right? And this is where num is actually declared. As soon as we hit this closing bracket, it's as if that function doesn't exist anymore, and all variables declared within that function are no longer kept in memory.
What if you go return num equals 5? But then you can't.
Oh, so if you well, first of all, you can't return
You can't
num
do that,
equals.
yeah, I know,
But if you
right.
just return 5,
Yeah.
well then wherever you're returning it to will now have its own access to it.
Right.
Does that make sense? So like if I said var x is equal to create num,
And
right?
Then,
Then I'd be good, yeah.
okay, thank you.
No problem. Okay, so I want to quickly point out.
Wait, just to go back to that, var x is equal to create num if that would work if within create num you're returning
Yes.
the value, right?
Yes.
But you have to have it returned.
Right, exactly. Right. So, all right. So let's go ahead and take a look at a little bit more scope. I think it'll be more fun if we do like some interactive stuff. So I'm going to have a function called func_a, okay? And this is going to have a num1 and a num2, okay? And then I'm going to have a function called func_b, which takes in num3 and num4. Everybody with me? And I'm going to console log num1, num2, num3, num4, and I'm going to console log num1, num2, num3, and num4. Okay, so one thing I need to do, of course, is invoke func_a, right? We're not even going to run this function if I don't invoke it. But also, func_b, right, exists within func_a. So the only way func_b is going to run is if I invoke it inside of func_a. So what I'm also going to do is invoke func_b. All right, so func_a takes in two numbers. We'll give it 1 and 2, and func_b takes in two numbers, 3 and 4. Any questions on what I just wrote up here?
Does it matter where you invoke func_b? You can put it right underneath func_a.
Does it matter where I invoke func_b? Could I do this? Yes, I could absolutely put this up here. The reason that, like, can I do that? Yeah, that should be fine. Because this is going to get hoisted up anyway. Right, so this is actually a really great point. Great point. So hoisting happens every time we create a new scope. Every time we create a new scope. So in our parent scope, right, we're going to hoist. And it's going to do this. And now, as soon as we invoke func_a, the first thing we have to do is do our hoisting again, right? So inside of that, we're going to then move our func_b up to the top of that scope. Make sense? Cool. All right, so here's what we want, right? We're going to invoke func_a with 1 and 2. Right, then we're going to go ahead and invoke func_b with 3 and 4. We're going to want to print out all of those, right? And then after, we're going to go ahead and print out all of those. Any predictions? Yeah. What's your name?
Eugenia.
Okay. Hi.
So I wonder if the last console log would print out num3 and num4.
Okay. All right. So you're thinking that this console log won't be able to print out 3 and 4. Does anyone agree with that?
No, but why?
If I call the function B without calling the function A inside function B,
So you cannot call function B from outside of function A. So what are you saying?
This one, last one, console log, is it to print out num1 and num2 is undefined?
So you think it's going to print out num1 and num2 is undefined. Why?
Because I'm not calling the function A, I'm not passing any.
But we're inside of function A.
So it erased together.
The placeholder.
Right. So actually, Eugenia, yeah, is correct here. What's actually going to happen is we're going to invoke function A, right? We get 1 and 2. Num1 is equal to 1. Num2 is equal to 2, right? We're then going to invoke function B, right? Function B gets invoked, right? So now we're going to pass 3 to function B, and we're going to pass 4 to num4.
I'm asking if there is no call for function A below the function.
Then nothing will run at all.
Okay, so function B inside will never be called.
Correct, because function B running at all is dependent on function A running at all,
Yeah.
right?
Same code block, right? It's the same function. Right?
Yeah. Yes.
So I understand why 3 and 4 can't be printed in the second console log, but I was expecting to see 1, 2, 3, 4 from the first console log, and then 1, 2, undefined.
Ah, that's a great point, right? Why don't we get undefined?
I guess the variables aren't declared.
They're not even declared, right? At this point right here, 3 and 4 are like, all right. So we did that growth check, right? We checked right here. We're like, all right, do we have 3 and 4? No, we don't. Let's go to our parent. Does our parent have 3 and 4? No, it doesn't, right? Because it's our parent didn't have it, right? Then therefore it's undefined. Now check this out. This is where it gets kind of neat, right? Let's go ahead and say var num3 is equal to 5 and var num4 is equal to 6. All right, this is getting kind of funky, right? Because now it's like, what's going to happen here? We going to still throw an error? Yeah.
No.
What was your name, by the way?
Priya.
Priya. You say no? Why?
No error, because the parent function has defined those variables.
So let's go ahead and do that. Now, what about here, though? What about this innermost console log? What do we think this is going to print out?
That'll still print out.
Yeah, so this will totally, you think this is going to, and why is that?
Because it'll give priority to the most local.
Exactly. So I think when I first learned scope, that definition wasn't said to me, but I think that's something very important to understand. A more local scope can always override a parent scope. Okay? So you can redefine variables locally and not worry about what the parent had it defined as. This is good and it's dangerous. Okay? It's dangerous because if you're trying to rely on a parent function's value, right, then you defining it locally is going to totally mess that up. It's good because, again, it gives you that freedom of not having to worry about what's going on around this function. Any function that you write anywhere in your code can operate independently from everything else in the code. That is why functions are fantastic at what they do and great for modular programming. All right, let's go ahead and run this, and we'll see exactly what you just talked about. Does this help clear things up? Everybody feel good about this?
Can we just write it down?
Sure, of course.
Is this being recorded?
Yes, this whole lecture is being recorded. And, check it out, I'm recording the right screen this time. So, we got a, yeah, it's good. It's good. Any questions on this? All right. Man, we really had a conversation because this lecture, I'm like looking at the slides right now and I'm like, I already covered hoisting, right? Like we briefly talked about the global scope. I'm going to mention that again in a second. Yeah.
So basically, when functions look for variables, they only go outside of to the parent. They never go inside.
Correct. They will never look for their child. Exactly.
Okay. So we'll just keep that in mind.
Yeah. Yes.
So since functions get listed up first, basically, and then its variables, function B is within function A, and then it's console logging 1, 2, 3, 4 because the ones that we declared function B and function A are more local to function A and B than the variables we set on top.
Right, so you're talking about during the invocation of where is my mouse? Okay, during the invocation of function B, right? At that very moment, we declare a local set of num3 and num4. At that very moment, right? And so when we go ahead and do that, we still have these in existence. But when we go to console log right here, we didn't need to go reach out for it, right? JavaScript didn't have to go save us from an error. And that's why we're able to console log 1, 2, 3, 4 right there. Does that answer that?
Yeah, but how come it's not used in the second console?
It is used here. You're saying here?
Yeah, not the variables like when we did it without them. Why is 3 and 4 not used there?
So when I didn't do this, you're saying?
Yeah.
Why are we getting an error here? Right, so just because we invoked 3, like right here, function B has access to num3 and num4. By the way, I should also point this out. This right here is like me saying var num3 and var num4.
So we can move it inside.
By default, this is what's happening. Okay? Whatever's written in here is treated as if it's var. Okay? Because conventionally, right, anything declared here will only exist within that functional scope. You with me? Okay, so now as soon as this inner function, func B, ends, so line 10 executes now, right? We pass func B, num3 and num4, right? Now we're going to console log 1, 2, 3, 4, just like we saw. Okay? Func B, line 8, ends. There's nothing left to do. There's nothing left to return. We're done. Okay? We now move on to line 9. At line 9, we console log num1, num2, num3, num4. Num1 and 2 are totally cool, right? They're totally in existence right now because func A has access to them. Num3 and 4 do not exist because they don't exist within the scope of func A or any parent to func A. Just because they existed in func B, right, doesn't mean that they exist in func A. Func B is the child to func A in this case, right? So just because they were defined at this brief moment on line 8, the minute that this function actually ended its execution, num3 and num4 were gone. And that's why we get that error on line 9. Yes?
If you move those variables down underneath calling the func A, it comes up 1, 2, the second line comes up 1, or the second console log for func B comes up 1, 2, and undefined.
If I do what?
If you take those variables at the top and move them, the ones that you commented out, and move them below func A.
Right. So, yes. Right, and that has to do with hoisting again, right? So if I did something like this, right, actually I can even lower it, really, it doesn't matter. If I put it all the way down here, right, we're going to hoist up our func A, but then we're going to hoist up, right after that, var num3, right, and var num4, just like that. And so at that point, if we did something like this, right, now we're going to have console log of num1, 2, 3, 4 with 1, 2 undefined, exactly. Good call. And that's just another example of hoisting. Yes?
The one thing that my brain is trying to get over right now is the fact that when you call func B, it's actually, it feels like it's happening outside of func B, the function func B, because it's called outside, but I know that it's just passing 3 and 4 with inside function. And so I'm thinking about that the right way, right?
I actually am not sure what you're trying to say. Can you please?
The whole thing about looking at parent functions for variables, right? Like when it's looking for num3 and num4, func B B is happening outside of the function of the curly braces for func B. Like the invocation is happening outside.
Yes.
So yeah, okay. I think I understand. I'm just trying to make sure I think.
So imagine this though. That's no different than func A being invoked outside of the curly braces for func A, right?
Yeah. And if you put like func B 3-4 outside of that, yeah.
Yep, you'll get an error. You get an error. Cool. So yeah, yeah, I think that's all I can really do on that until we dive into the next lecture, which is a step beyond what we're going over now. Yeah.
So I don't know. In my head, the way I see it is, it's like the movie Inception. So it's like you're going within one world, another world, and if let's say there's something missing in the inner function, it will just go outward until it reaches the main like parent function, and if it's still not there, it's just going to give you an error.
Does anyone know what that's called? Continuing a trace until you can't find anything? It has an ending. Something we're going to learn about next week. It's actually recursion. It's recursion. And I don't want to go too much into it, but that's actually what's happening here. It's performing recursively, looking for a variable. And it's going to continue looking until it finds one. Yes,
If it doesn't,
it errors.
Oh.
Did you mention that there was 3 things that are hoisted? So you said functions are hoisted, variables are hoisted.
No, there's 3 steps during hoisting. The first is hoisting of functions. The second is hoisting of variables. And finally, we can run our code.
The third one just
Yeah, execute in order. Yes?
Is there additional like sub-levels for if-else statements or for loops?
Great question. So I've kind of been avoiding our logic and our loops intentionally because var is terrible. Hear me out. Here's what happens with var, right? So let's say let's forget about func A and func B. Let's make this a little bit simpler, okay? Let's just say function looper, okay? Which is going to take in, I don't know, A, okay? And all it's going to do is it's going to loop from I is equal to 0, I is less than A, I plus plus, and it's just going to console log I. Okay? Everybody with me? Looper seems pretty straightforward. Okay, here's where it gets weird. What if I did something like this? Because this is what you're getting at, right?
Yeah.
What happens with the console log of high here? Who thinks we're going to get an error? Who thinks we're not going to get an error? Who thinks that we should get an error, but we're not going to get an error? Yeah, so that's exactly what's going to happen. We're actually totally going to have access, and I'll even prove that. Let me put something here. Okay. Yeah.
Because it automatically understands it, right?
So what creates a new scope with var? Functions. That's it. No other exceptions. It doesn't matter if it's an if statement, a for loop, whatever. Okay? It does not matter. When I go into let with you at the end of this course, okay, we're going to talk about why let is more realistic for what other languages do. If you come from other languages, this is insane. Because you look at this, and now you've declared what's considered a garbage variable, right? And it's accessible after a loop is done. Even I, which was just declared for the purposes of this loop, is totally accessible to us afterward. Another thing that's kind of nasty about var is I can go ahead and do something like this. That seems weird, right? Why am I declaring the same variable 3 times and I'm not getting an error? Yeah, that's not an error. So that's kind of bad about var as well, okay? And so we'll talk about the let alternative at another time. what I think is more important for now is to have a brief talk about closure. Here's what I'd like to do. I want to pause here for a second. No, okay, so, where are we? All right, let's add a little bit of realism to this, okay? So one thing that we're doing here is we're console logging, and as we know, console logging is only helpful to us, the developers, right? That doesn't allow us to use stuff in other places, right? Only returning a value from a function will let us use that value later. Okay, so let's go ahead and this is going to seem kind of silly. Let's go ahead and just do something like this. I'm going to comment out all of that, okay? And I'm just going to make func_a return num1 plus num2. Everybody with me? Right? So if I say var x is equal to func_a 1, 2, right? What is the value of x after this code runs? 3, right? Because I'm going to invoke, I'm just making sure that we didn't lose the whole, right? We just covered a lot. So like, let's go back to like our roots here, right? I'm just invoking a function with 1 and 2 and returning 1 plus 2. That 1 plus 2 gets evaluated as 3, and that gets returned back to the place that it came from, right? 3 right now is the value here once this got evaluated. Now x is equal to 3, right? Okay, that may seem silly. But what I'm going to say is this. Everything that I teach you is no different than that. The thing that people do with closure that makes it such a difficult lecture is that they imagine it as this unique situation. The only thing that I'm going to change now is what we are returning. What we are returning. Okay? So up until this point, you've never returned a function, right? You've always returned a number or a string or something like that. But the rules do not change just because you're returning a function. Does that make sense? Everybody with me? Okay, so keep that in mind throughout this entire lecture. One second, guys, sorry. All right, looks like we're doing PDF. That's fine. Okay, so, all right, let's do another example here. All right, now let's go ahead and just extrapolate on this. All right, we have what we have here, right? And this is just a function returning some value. Instead of returning some value, let's go ahead and add func_b back in. But just like before, okay, let's just go ahead and return num1 plus num2 plus num3 plus num4. Okay? All I did was change that inner thing to console log. Now, what am I going to get as the value of x? Yeah, it's not a trick. I didn't do anything. All I did was define a function, right? I did not use it. Nothing up my sleeve. That's the whole idea here. I'm not trying to throw you off. I'm trying to keep you on the same pace as me. Me defining a function does not invoke it. Doesn't matter. I could just return 5 here or whatever, right? I'm returning num1 plus num2. Same thing happens. We call this function. Sure, this gets hoisted up to the top, right? It's in memory and stuff. But then we just go ahead and return 1 plus 2. We get 3 here, and we evaluate x to 3. Okay. I'm also going to go ahead and add this, console log x, okay, so that we can actually see that this is 3. Okay, now, instead of me returning num1 plus num2, here's what I'm going to do. I'm going to return func_b invoked with 3 and 4. You still with me here, right? So now what I'm doing is I'm calling func A with 1 and 2, right? Num1 becomes 1, num2 becomes 2, right? At that point, we're going to return func B of 3 and 4. Because this is not a primitive type or like a data type that we can work with, we need to go ahead and change our viewport again, right? We need to change what we're thinking about. And now we need to go into func B, right? And at that very moment, right, 3 and 4 get passed in here, right? So we're going to have func B as 3, num3 is going to be 3, num4 is going to be 4, and we're going to return 1 plus 2 plus 3 plus 4, right, which is 10. Right, with me? That return of 10 goes back to the line of code that called it, right here, which then evaluates the 10, and now we're going to return 10 back out. That's going to show up here, right, and then var x is going to be 10. Everybody with me, right? We added another layer of complexity here because now we're basically sending this return value through 2 levels of complexity. Back to our inception reference from before, right? Basically, like this inner one is shipping out the actual answer, and then this is shipping out the answer back to here.
You can like also change, like it doesn't have to be plus, it could be times or whatever.
Whatever, yeah, it doesn't matter. I'm using plus for simplicity purposes, okay? All right, it's about to get weird. Stay with me. So now instead of me invoking func B, I'm going to do this. Now what is the value of x?
That function.
Yes, that function becomes the value of x. Now if that seems weird, consider this, right? We invoked it with 1, 2, right? This function doesn't run ever. Remember, the only thing that makes this function run is the invocation of it, right? And we're just simply going to return func B back out. So at this moment, it's like we just ripped out function B from its position in line, right? And now x represents func B. Okay, and let me show you that. If I console log x, we literally can see that x is now function func B. Anyone need me to go over that again? Yeah? All right, one more time. Okay, so here we go. On line 8, we're invoking function A with 1 and 2. We put 1 and 2 right here. Function B never runs. There's no invocation call to it, right? There's nothing here with a set of parentheses around func B. However, this line of code, which is our return statement, just says return func B, not the invocation of func B. Literally return function B. And at that moment, that return gets shipped right to here. And x now takes over as func B. Yes?
So what, say func B just became like a pseudo variable? It's just putting, oh, okay, we're just calling out func B. Is that what's happening?
Yeah, so I could have totally not even named this thing if I want. I could have just said this. If I want, I didn't want to throw this in the mix, but I could just do that. It like doesn't even need to have a name, right? Who cares? Because it's going into the value of x anyway. But yeah. Does that answer that question?
Yeah.
Okay.
So you're doing this conceivably to be able to run func B outside, whereas before when you invoked it outside, you got an error. But if you return it and assign it to x, now you can manipulate that inner function outside of this, the parent scope.
Actually, no. So we were always able to depend on the parent scope. That doesn't change. What's actually strange now, which you might be wondering, is if I'm over here with this variable, right, do I have access to num1 and num2 anymore? Right? That's the weird part here. Because I invoked func A and ripped out func B, right, what happens to the context of func B? Right? Func B depended on stuff from func A, right? You guys see why that's weird? Right? This function here that's inside, scope-wise, right, depended on function A. But essentially, when I returned it out, I ripped it out, right? And now it's like it's not even in here anymore, sort of, right? It's like over here, and so technically we shouldn't know anything that happened in func A. Yes?
So now the question is, why do we put, when we console log it, we print actually, function func B, as opposed to just func B? And I thought that this is because we declare the function, although we never invoked it, right? And then when we return func B, that's how the compiler knows that that's a function.
Yes.
But then you said that function, a function, when we declare a function, would not be even called func B to begin with.
So x.
No. So go back to the func A and
yes.
the declaration of the second function inside the func A.
Okay, yes.
Yeah, second line. So if you take out the func B name, okay?
Sure.
And then you said we can totally do that.
Yes, you can do this.
So now when we print func B or return func B,
This won't ever run.
okay, so why do we, when we print it out, we get that it's a function?
Because it knows that it's because what is it going to print out? Console log is like, hey, I got this function.
String func B. Because that,
Oh, you want it to actually print out the contents.
no, I could see that in the result.
Yes.
We get the return, not func B, but function.
Yes. That's how console log prints out that it's a function.
But how does it know that it's a function?
Oh, I'm part of probably the console log mechanics. Like, console log is taking in a function. Like, right now you're passing a function to console log, and it just, like, as its parameter, it probably checks if type of thing is equal to a function. Let's go ahead and do kind of let's go ahead and do it the anonymous way. This is called an anonymous function because it doesn't have a name. Okay, if we do it like this, it'll just say function.
But that I understand because you explicitly said function.
Isn't it just the syntax? It knows
Yeah,
that
yeah.
function parentheses something is a function.
Yeah, I mean, I wouldn't think too much like so it's just the way that it just knows that it's a function because that's what console.log is doing. Like the log method of console is looking and going, "Oh, this thing's a function." The same way you can use type of to look at the type and see that it's a function. It's probably doing it like that. Yeah.
I thought only a function expression can be
You mean like var x is equal to function blah blah blah? That's not technically anonymous. I mean it is, right? But no, you can use anonymous functions anywhere. I just have avoided talking about them because they're confusing. I think it's easier to understand it the other way that I wrote it, which is just like this. Yes.
So can you console log x and pass parameters to x within that console log?
I'm getting there. Does everybody understand this? Okay, I now have, and this is a lot to take in. Honestly, this is but the thing is like, right? All I'm doing is keeping your head straight at each step of the way. I'm not changing the rules of things that we know. Okay, I'm saying x is equal to func A past 1 and 2. Right? At that point, all we're doing is returning func B, which is this whole thing ripped out and put here. Okay. So now we have a function, right? Well, with a function, we can totally do something, right? We can invoke it. So yes, now I can go ahead and invoke this thing, right? What does function x take? It takes in two parameters, right? num3 and num4. So I'm going to pass it 3 and 4. Now, how many of us think we're going to get 10? How many people think we're going to get an error? What about, who has no idea? Okay, so actually, we're going to get 10. And this is the weird part, okay? This is the weird part. Stay with me, right? This is the way that it is because this is the only way that it could be. Okay? No, I know that sounds weird, but hear me out, right? Like, imagine that we ripped out a function and it couldn't depend on anything from its original context, right? 90% of functions that we return would be broken, right? Like, for example, this function b only works because it has a num 1, 2, 3, and 4. As soon as I put it in this context over here by itself, right, it essentially, right, would not work because it only now would have access to 3 and 4. And it would error out. Does that make sense? Okay, so this is actually what closure is. The moment that you return a function from a function, it keeps the original scope in memory.
Repeat that.
Anytime you return a function from a function, it keeps that parent function scope active in its memory.
So does it keep the num1 and num2 active memory?
Yes. So in this case, whenever I invoke and whenever I invoke x, num1 and num2 will always be 1 and 2. So I can go ahead and now invoke console log of x over here, right? And I can give it, I don't know, 5 and 6. And now it's going to take 1 plus 2 plus 5 plus 6, right? Which is 14. Nailed that math. Yeah.
I'm sorry, so you're just feeding 5 and 6 into function B.
Yeah, essentially, right? But the weird thing here is that it had to remember from where it came. Because if it didn't, num1 and num2 would be undefined. It is weird, but it's the only way that it could physically work. This is the only way that we can have this amazing capability to return functions from other functions, right? If we didn't give this closure capability, right, we physically would not be able to return 95% of functions. This is a must. That is why we have closure, because we can't not have it. Yeah.
Is this principle like shared across all programming languages?
I don't know the answer to that question.
Or not all, but like the popular ones.
I know that MATLAB does it. I don't know.
Just curious if there's.
Yeah. I could do a quick Google on that. I honestly, yeah. After the lecture, definitely, I'll look into that a little bit more. But off the top of my head, I do not know. Yeah.
I don't know how much more depth we're going to go into today, but do you mind like reading the problem from last night, the New Jersey sales tax one? I feel like that's how they wanted us to solve this problem. Was the way you're doing this right now.
Okay, sure. I don't think we're gonna have time today, but tomorrow I will absolutely spend a couple more times. I'm gonna even give you closure like homework basically tomorrow. I think today like it's enough to see. You know, like sometimes when you're like studying for an exam, if you study 2 nights before, you like freak yourself out, right? But then the next day you're like feel much like sits in almost like, you know, it's like there's a theory in psychology called memory consolidation that when you go to sleep, somehow like those synapses like coordinate, and that's how you strengthen those memories. You know, I think that has some kind of backing to it. Like that has some kind of foundation where like this may be confusing to you right now, and it probably still will be for a little bit. It really is one of those topics. This is it, by the way, but like we're here. But this is like one of those things that really just it blew my mind. The first time I saw it, I had no idea what was going on. And I think that it's important to note that this is the only way that it could work. That's really important. Yes. So could I do this? Oh, put this like here? I'm not sure. Like this? Wow. Okay. Believe it or not, the answer is yes. So this is something else that I don't want to get into. This is called an iffy. Okay? But what you are essentially doing, all right, stay with me. So yeah, this actually will work. If you do, okay, because of this. Yeah, so let's talk about why this will work. All right, stay with me. So what you're doing is forget about this 3-4. Everybody with me? Forgetting about that 3-4. We do things as normal, right? Func A 1, 2 needs to evaluate. So we go to func A, pass it 1 and 2. What does func A return? It returns a function, right? So now when we get func B, that gets shipped back to there, right? This becomes func B, and it's immediately invoked with 3 and 4. You see that? So func B gets passed back right here. That doesn't do anything, by the way. You can totally still see it. But yeah, you pass back func B right there, and then immediately invoke it with 3 and 4. It's called an iffy. What?
Can you just go a little more slowly? What do you mean you're passing func B back there?
So what happens when you invoke func A with 1 and 2?
Oh, I see. You're returning func.
Func B gets returned out. So this essentially represents func B.
Right.
But if you did it that way, then it wouldn't work.
This?
No, if you replace func B with
No, because you don't. The word func B means nothing at this level. So there's disadvantages to this syntax. One is reusability, right? Let's say you wanted to remember num1 and num2. Like, I'm trying to think of a good example. Maybe this parent function takes in like name and age. Something that you would not want to change. But it returns something that changes every day. I don't know, maybe attendance checker, right? And you pass attendance checker like a yes, a true or false or something like that. And it remembers what the name and the age was from its original scope. Let's go ahead and write that really quick so I don't seem like I'm crazy. So here's a function called like name. Let's call it like attendance. Okay, and it takes in a name and an age. Okay? And then here we're going to return I'll call it function daily attendance, something like that, which just takes in a Boolean of true or false. Okay? Console log, okay, name is here today. So if bool else okay. Okay, so now let's go ahead and make our attendance for everybody. Okay, so we're going to have var attendance, and I'm going to pass it Corey. I'm going to pass it, so we'll say var Corey is equal to attendance. Var Lisa is equal to attendance. Okay, var okay. This is all I've done so far. So, what is the let's take a moment to take this in, okay? I have a function here called attendance, right? And a function inside of it called daily attendance. Now, daily attendance requires a name and an age, really just the name in this case, right, to actually operate properly, right? I'm going to check if this Boolean is true, console log name blank is here today. Otherwise, console log name blank is not here today. Okay, that's what daily attendance does. So when I go ahead and I invoke attendance, right, I'm passing attendance a name and an age. At that very moment, we're going to return daily attendance, right? And so now, Corey, Lisa, and David, all these variables, okay, are functions, right, that represent the daily attendance for each of them. For each of them. Now, this is important. They all have their own closure. Each time that I called attendance, I got back daily attendance as a function. but the closure was created at that moment with that name and age in mind. So if I say now console log Corey, right, that is just going to come back as a function of daily attendance, right? But now I can go ahead and invoke Corey with true, because daily attendance takes a Boolean, and it'll say, okay, Corey is here today, right? Cool. Then I'm going to say console log Lisa invoked false. Where is that undefined coming from? Oh, yeah, see? Yeah, exactly. So I actually don't need to do that. I don't need to console log this. So this is important, right? When I made a function for Lisa, I didn't want to forget everything that the function Corey was remembering about Corey, right? For the attendance, the daily attendance function to work appropriately for Corey, it needs to remember that my name is Corey, right? If when I did this, it just changed the context of attendance to now represent Lisa, all of a sudden everything that I did here doesn't make any sense. And then again, on line 11, when I declared David, right, and made another invocation of the attendance function, if all of a sudden, like, that overrode the original context of the attendance function, then that wouldn't work either. So they each have their own individual scope. And that's how we get that. Yes?
How would you then access the age?
So how would I go, I mean, okay.
Because now it's locked.
Yes, so this is actually a great thing. You don't want to access their age. You basically want to lock it in.
How would you even get at it from the code? Like, how would you?
You can't.
Yeah, that's what I thought.
Yeah. It's actually called a private variable.
Right.
And there is no real private variables in JavaScript. So this is the closest you'll find. When you're making games, this is kind of what you want to do. This is your approach. Because you want to create, I don't want to go into that. I'm finding myself going on a tangent right now, but yeah, we'll leave it at that. Yes?
Yeah, so this, finding the age, it feels a lot like the last one. I still don't quite understand why 1 and 2. I know that they are available for function B, num1 and 2, function B in the previous example, but why would those be available when 25, 45, and 34?
What do you mean? These are available. I could say like name plus. Forget about that. Forget that was ever said. Don't worry about it.
Is it available?
In what regards?
I think we got confused when you say it's not.
The question that he asked deals with, can I access name and age outside of could I at this point with just this, forgetting about every other declaration here, okay, forget about all this, right? What if I just want to know the name and the age that were passed in here? That's what he was asking. That's not what we were talking about. What we're dealing with is we've called, okay, let's break this down by getting rid of Lisa and David here, okay? On line 9, I go ahead and I invoke, by the way, I'm not diving into that private variable thing. That is beyond the scope of this course. If you want to talk about it outside of this lecture, I'd be more than happy to. It is a little bit beyond what we should be talking about here. But I will say this. I will go through this one more time with the logic, okay? Line 9 is the first piece of code that actually executes, right? It's the first thing that actually happens. Boom. Function declared, don't touch it. Same rule. I then call the attendance function with the parameters Corey and 25. Okay? So now we go to attendance with Corey and 25. And at this point, we return daily attendance. Okay? That's it. Daily attendance, which is the function, gets shipped right to here. And now Corey represents the daily attendance function, right? Now, when we just spoke about closure, right, this daily attendance function for Corey needs to remember the Corey name and the age for Corey. Okay? With me? So, at this point, we have the daily attendance function ripped out right here. Now, I want to be able to invoke daily attendance. What does daily attendance take? It takes in a Boolean, right? So I'm going to pass it true. When I go ahead and pass it true, it's going to say if Boolean is true. Well, it is true. So console log name. Wait a second, I don't have a name. This function, which is right here, doesn't have a name. So where are we going to get the name from? Well, normally we go to our parent function. But because we're over here, we don't really have a parent function with a name. Okay, but we were initially returned out of a function. So instead of throwing an error, what we do is this return function is going to remember where it came from. So when we ripped out daily attendance and put it over here, it's like it made a side note that if we ever use daily attendance, the name is Corey and the age is 25. And that's why when we run line 13, we get this printout, Corey is here today. Yeah.
It's like creating an object almost.
So, well, a function is an object, right? So yeah. But I wouldn't, in this case, say think of it like that. Yeah.
I think I might have just confused myself.
I think we should probably table this, honestly, for the rest of today. But if you have a particular question, I'm going to end this lecture now because we're like really cutting into at least having a little bit of workshop time. But what I'd like to add is one more piece. So let's go ahead and now say we do this second invocation. Okay, we do the second call to the attendance function, right? So we already did the invocation of attendance and set it equal to Corey. Right now, Corey represents the return daily attendance function from this initial function. When we call attendance again, it's as if we never called it the first time. It's completely independent. So when I call attendance and I pass it Lisa and 45, right, it now is going to get back a daily attendance function, which closes over the scope of Lisa and 45. Which is why, when I go ahead and let that run, it remembers Lisa for line 14, but it keeps Corey for line 13, because they each have their own scope. That is what the closure is doing here. And you can see that right there. Okay. I think that's enough on closure for today. I think that this last example was probably a little bit further than I wanted to go with it, but I think it kind of gives you a good sight of actual context for this, right? Like, you might want to think about a function that would return a function, and then that function has a use case. And here's a pretty good example of that. On that note, is there any other questions for today? Yeah. Okay, good. You guys made it through probably the second hardest lecture of this course. And remember, but remember, it's not a hard lecture, right? Because the interesting thing about this, and always keep this in mind, is that this is the only thing that could happen, right? Like, if we did this any other way, we would get errors. This is the only possible way things will work. Yes?
We have to understand why daily attendance is a side note where it came from, of that those original two variables, or the parameters of the past.
I'm sorry?
But do you have to understand specifically why it makes those parameters available?
So why closure happens?
Yeah.
Closure happens because imagine this. If I try to use this, remember, attendance is returning me daily attendance. The invocation of attendance is returning daily attendance, right? When I go ahead and use daily attendance, name is being used. Where did name come from? Daily attendance has no idea what name is, right? So the only thing that knows about name when you're talking about daily attendance is its parent, attendance. But what's weird here is that we ripped out daily attendance right here, right? We basically took daily attendance and stuck it into the Corey variable. So how the heck does it say Corey is here today when I go ahead and I invoke Corey? Well, that doesn't really make sense, because if we didn't have closure, then it would say undefined is here today, or reference error. I have no idea what you're talking about, right? But it remembered Corey from that initial situation that it was in, and that is the closure that was created.
Why?
Because there's no other option.
Well, why does it work?
Oh, like why in the actual syntax behind the scenes? Like,
Yeah, like
this is what is in the JavaScript, like, I talked about ECMAScript, right? Like kind of being the dictionary for JavaScript. This is the specification for how JavaScript should operate. This is part of the rules of being a functional programming language. If we did not let it work like this, we could not return functions from functions the way that we'd like to. This is the way that it is so that we can actually pass functions around, so that we can return them from functions, so we can take functions in as parameters. That is why we do this. The actual mechanics of how it's going on in the background, you'd have to read into the specification on how that actually operates. But that is why, though, right? That makes sense. This is the only thing that could happen without throwing an error.
I understand the purpose.
Yes.
But just
The implementation, a lot of these methods that we go over, we won't even discuss the implementation in this class. But this specifically, I would imagine, is a fairly complex form of implementation that they have to go through to keep this in mind, right? Look into garbage, if you're interested in this, like look into something called garbage collection. And that will probably give you most of the solutions that you want about this. But this is going to be a very complex implementation problem. Yeah.
Not to make things more confusing, but I have two more questions. The first one is, can closure happen within an inner function?
So can it be like 3 levels deep?
Correct.
Yeah. Yeah.
And my
How
second
deep?
question, in terms of making your code tidy and readable, is this a good form, or is this something that's inevitable when you type in a program? Is this like, because I mean, when you see it at face value, Corey should just be a variable, but instead it became a function. So in terms of readability, I mean, there's still some confusion. You just have to dig a little bit deeper. But in terms of best practices, I mean, is this something that's just, inevitable? This is just what happens in JavaScript.
So to answer your question, this is inevitable. How many of you guys have heard of Node? Okay, not that many. That's okay. Node is how we run JavaScript on our computer. Okay. What's really cool about Node, right? Think about it. Mind-blowing realization here is that all of the code that you've ever written in JavaScript has been on the internet, right? Why can't we do it on our computer? Every other language we could just write it right on our computer, but JavaScript we can't. The difference is, in short, JavaScript requires an engine, something to understand what we're saying and convert it into machine signals while it's running. Other code gets compiled immediately down into machine code before it can actually execute. Okay, so the reason why I bring this up is Node is what we use all of the time in terms of server code. Like when we're actually running a server running on our computer. And all the time we link to these things called packages or modules. You might write this entire thing of code that I want nothing to do with. I don't want to write it myself. You wrote it. I'm going to just use it. Okay? A lot of times when I'll go ahead and invoke an instance, like a function that you wrote, and you'll return back to me something that I can use. That is when closure happens all of the time. Like literally, like every package that you use, like you even use Express, right? When you use Express, you see that. You invoke Express and it returns back a function. Like a lot of times you'll invoke something and you'll get back a function that you get to use. The idea behind it goes back to that privacy thing, which I don't want to go too much into. But yeah, all the time you'll see this. You won't write it that often. You won't like implement this yourself that often. A lot of times you'll be this guy. Like, you'll just know about this. You'll be like, ooh, I heard about this attendance module. All I have to do is pass it a name and an age, and now I have this function that I can use just to mark someone present or false. Does that make sense? That's the point behind it. Yeah. Yes.
I have a question, but it might not be a good one. So
I'm sure it's fine.
So I'm stuck on the idea of like attendance being, or Corey or attendance being like saved in memory. So like if you, does that mean that every time now you run attendance after it, that it's going to remember that it's Corey 25?
No. Every time I run Corey after it, which is attendance, which is daily attendance, it will remember Corey and 25.
So if you did, so then after var Corey, if you made another line that just said, if you modify, I guess if you, yeah, exactly. What happens?
Well, it's going to go ahead and invoke attendance again with David and 35.
This doesn't get assigned to any variable.
It doesn't get assigned, so it's just going to basically dissipate. I made up these ages. I'm not 25.
Okay, so it's not really. Okay, it doesn't override.
No. And each instance of daily attendance will keep its own memory. Okay. I feel like that was a mouthful. Like, I'm tired. So, on that note, I'm going to, I think this was a big lecture today.